Hello everyone. So glad to meet you all virtually. My name is Susma Pradhan. I am with Onsite Water Protection Branch working as a non-point source program coordinator. This is just the roadmap of my presentation today. I will start with what is environmental pollution. We'll talk briefly about non-point source rules and regulations, which entities are responsible for running this program in the state level, and at the end, I will be talking about some non-point source projects we are involved with. So, what is environmental pollution? Generally speaking, environmental pollution is an introduction of contaminants or pollutants into a natural environment that causes instability, disorder, or harm to the ecosystem. Pollutants can be chemical substances or energy such as noise, heat, or light. Pollutants can be foreign substances or naturally occurring substances. Pollutants are being introduced into the environment at the rate which far exceeds the rate at which it can accommodate them. The most common pollutants are usually chemicals, garbage, and wastewater. Environmental pollution is happening in many parts of the world, especially in the form of air and water pollution. Environmental pollution is a broad concept which includes pollution of various biological and physical components of the planet. Generally speaking, there are many types of environmental pollution, but the most important ones are air pollution, water pollution, and land contamination. However, we should not overlook noise pollution, thermal pollution, and radiation pollution because these pollutions are increasing rapidly in the last few decades. Human activity is adding these pollutions to the environment at much higher rate than it can accommodate them. However, for this presentation, our focus is on water pollution only. We know there are many potential sources of water quality problems. Based upon how pollutants are being delivered to water bodies, the U.S. Environmental Protection Agency has classified the sources of pollutions uh, either as a point sources or as a non-point sources. Any source of pollution that enters the waterway through a single identifiable conveyance, generally large pipes, then it is called point source, such as wastewater discharge to rivers from sewage treatment plants. And any sources of pollutions that reaches waterway through some means other than direct discharge from a pipe, such as rainfall runoff, atmospheric deposition, and groundwater flow, it is called non-point source pollution. Non-point sources are often difficult to identify. They represent the cumulative effects of many small activities such as pesticides or fertilizer application, construction site runoff, or the use of on-site wastewater treatment system, which is also called septic system, or decentralized wastewater treatment system. This slide presents point and non-point source pollutions. What we see here is wastewater treatment plants, rural homes, suburban development, cropland, animal feedlots, and factories all are contributing pollutions to nearby water body. As described in previous slide, the point source pollution comes from a discrete point. It is a pollution discharges from a single identifiable source. So in this slide, pollutions from wastewater treatment plants and factories all falls under point source pollution. However, non-point source pollutions comes from many different sources and they are diffuse in nature. There will be no involvement of discrete points. So pollution from rest of the sources in the slides are example of an non-point source pollution. However, our focus today is on non-point source pollution only. So where does non-point source pollution come from? Non-point source pollution is caused by rainfall or snowmelt moving over and through the ground. As runoff, the flows over surfaces, including our streets, parking lots, yards, construction sites, farms and forests, it picks up the things in its path, including fertilizer, loose soil, animal waste, leaking motor oil, and chemicals such as pesticides and herbicides, and pathogens like bacteria and viruses, and anything in its path. This runoff then drains either directly to a water body or to a stormwater drain. And the stormwater drain that eventually flows into the water body and carries with it all the pollutants it has picked up. In the next few slides, I will be talking about, giving an example of non-point source pollution. What we see here is a surface runoff from agricultural land. As runoff flows over farms, it picks up the things in its path, such as fertilizer, sediments, and animal waste. This runoff drains directly to the nearby water body. Since it is not coming from a single discrete source, as well as no direct pipe is involved, it falls under the non-point source pollution category. What we see here is wastewater surfacing from malfunctioning septic system. So what happens to this influent sitting underground? It might infiltrate into the ground or it might run off to the nearby water bodies. Since pollution from septic system is diffuse in nature and not delivering to the nearby water body through a single discrete conveyance, septic systems are non-point source pollution. This picture shows runoff with sediments from construction sites, another example of non-point source pollution. This chart shows different sources of pollution contributing to surface water pollution. According to the National River and Stream Assessment conducted by Environmental Protection Agency, 65% of surface water pollution is due to non-point source. Municipalities contributes 17%, industries 9%, and remaining 9% comes from other sources such as atmospheric depositions and things like that nature. In next few slides, I will be talking about how non-point source pollutions are being handled and what entities are responsible for removing or reducing non-point source pollution. As there were no rules and regulations and management entities, our waters were getting highly polluted. Federal Water Pollution Act, which is commonly referred to as the Clean Water Act, that was passed in 1972. The objective of the Clean Water Act is to restore and maintain the chemical, physical, and biological integrity of the nation's water by preventing point and non-point sources, providing assistance to publicly owned treatment work for the improvement of wastewater treatment and maintaining the integrity of wetlands. The Clean Water Act of 1972 played vital role in improving nation's water quality, specifically by controlling pollution from industries and sewage treatment plants, which are point source pollution. However, it did not do good enough to control pollution from non-point pollution sources, and it remains the nation's leading source of water quality problem. To address these problems, Congress amended the Clean Water Act in 1987. Congress established the Non-Point Source Management Program under the Section 319 of the amendments. The Non-Point Source Management Program provides grants to states, territories, and tribes to implement non-point source pollution control management programs. In 1990, the U.S. Environmental Protection Agency began awarding grants to states, territories, and tribes with approved non-point source pollution management programs. By 1991, all 50 states and the territories had received EPA's approval. By 1995, 7 tribes also had received approval. EPA provides funds to state and tribal agencies. State and tribes then allocate funds through a competitive process to public and non-profit organizations to address current or potential non-point source The 319 grant program is administered by non-point source planning section in the Division of Water Resources within the Department of Environmental Quality. Each fiscal year, North Carolina receives $2 to $4 million to address non-point source pollution issues. 40% of the funding goes to supporting ongoing state non-point source program, and the remaining 60% of the funding made available through competitive grant programs to public and nonprofit organizations. The purpose of funding is to restore water bodies impaired by non-point source pollution. Proposals for fiscal year 2024 are now being solicited. North Carolina Department of Environmental Quality, Division of Water Resources is seeking proposals to implement watershed restoration plans that will help restore waters impaired by non-point source pollution. This grant is open to state and local governments, interested agencies, public and private nonprofit organizations, and academic institutions. Applicants also have an option to submit pre-proposal and get feedback and submit final proposal later on. March 15 is the pre-proposal submission deadline, and the final proposal submission deadline is midnight on May 6, 2024. And the selected proposals will be notified by Division of Water Resources on July 5th. For the purpose of non-point source pollution management, North Carolina Division of Water Resources has categorized non-point source pollution into 10 classes, which are listed in this slide. However, this presentation is focused on non-point source pollution from on-site wastewater treatment system only. For those of you who do not have much experience with on-site wastewater treatment system, which is also known as septic system, I am going to talk about it in next few slides. On-site systems are private wastewater treatment and disposal system for single-family home or cluster of homes or businesses that are not connected to a community sewer system. And on-site wastewater treatment systems use natural process and mechanical components to collect, treat, and disperse wastewater. On-site systems can effectively treat domestic wastewater and disperse it into environment and protect public health if closer attention is provided to inspection, operations, and management of the systems. Number of on-site system users increases every year as a result of population growth, development pressure, and high cost of public sewer systems. It is estimated that approximately 25% of homes nationally and 50% of the homes in North Carolina utilizes on-site wastewater treatment system. Few interesting facts about septic system concerns in North Carolina. According to Census 1990, North Carolina had the third highest number of homes served by septic system. 2018 on-site system assessment report published by National Environmental Science Center indicated that North Carolina had the highest number of new on-site system installation across the United States in 2015, 16, and 17. There are over 4 million occupied homes in North Carolina, and approximately 50% use on-site wastewater treatment system to collect, treat, and disperse their wastewater. This dependency within the state has remained relatively constant for more than 20 years. Septic systems are utilized in all 100 counties in North Carolina, and the number of users per county varies, ranging from 14% to 93% of the county's population. Approximately 800 septic systems have been installed since 1990, which averages about 27,600 systems per year. This is list of the projects I am involved as a primary investigator or co-primary investigator. Number 1, 2, number 5 are ongoing projects, and the remainings are list of the projects completed in last 5 years. I will be talking about ongoing projects as well as results from some of the recently completed projects in the next few slides. Clean Watersheds Needs Survey is the only national survey to estimate wastewater infrastructure improvement needs in the country. It is a joint effort by the U.S. Environmental Protection Agency, states, and the local organizations. The 2022 Clean Watersheds Needs Survey was started on March 1, 2022 and closed on the May 31st of 2023. The identification and the reporting of decentralized wastewater needs in North Carolina was a collaborative effort between the On-Site Water Protection Branch of Department of Health and Human Services and Department of Environmental Quality's Division of Water Infrastructure. The On-Site Wastewater Protection Branch developed a data collection and a cost assessment approach to estimate decentralized wastewater treatment system needs in the state for over 20 years period from 2022 to 2024 and submitted to EPA. Once the state-specific data collection and a cost estimation method was approved by the EPA, the decentralized wastewater treatment system data was gathered, documented, and entered into the EPA's data entry portal following the set of documents and guidelines and a criteria for clean water needs survey. Only decentralized wastewater treatment systems with surface dispersal were included in this survey. The average number of new, repair, replacement, and expansion permits for these decentralized systems across the states were some of the input used in the cost estimation tool to estimate the cost of decentralized facilities needs for over the 20 years. As mentioned earlier, the Clean Watershed Needs Survey is a comprehensive assessment of the capital cost needs to meet the water quality goal of the Clean Water Act. Every 4 years, the state and the EPA collects information and submit it to Congress. The survey data on capital investment needs are organized into 14 different categories, and the decentralized system need is one of them. Decentralized wastewater treatment needs category includes needs associated with the rehabilitation, replacement, or new installation of on-site wastewater treatment systems or cluster systems. It also includes the treatment portion of the decentralized sewage disposal technology. This is the only national survey to estimate wastewater infrastructure improvement needs in the country. EPA submits needs to the Congress, and the Congress is authorized to utilize the survey information to relocate the state revolving fund. Decentralized needs have been underreported in North Carolina and nationally. Even though 25% of the households nationally rely on decentralized system, decentralized needs reported were 7% of the total wastewater infrastructure needs and received only less than 1% of SRF funding assistance. This map shows distribution of decentralized wastewater treatment systems need by state in 2008. In the 2008 survey, only 26 states reported their decentralized system needs, and the total decentralized system needs reported in the 2008 survey were $23.9 billion, including North Carolina's $6 million. In the 2012 survey, only 27 states reported their needs, and those reported needs were 19% lower than what was reported in 2008 survey. States with the top three highest reported needs in 2012 survey was Florida with $10.3 billion, Maryland with $5 billion, and New Jersey with $2.2 billion. We submitted state-specific data collection and cost estimation method to EPA in May of 2022. And once the data collection and the cost estimation method was approved by the EPA, we started gathering decentralized system data and documenting and entering them into EPA's data entry portal. Only the decentralized wastewater treatment systems with subsurface dispersal were included in this survey. It was assumed that the surface dispersal systems needs are very small. The average number of new, repair, replacement, addition, and expansion permits for those systems across the state with some of the input used in the cost estimation tool to estimate cost of decentralized facilities needs over the next 20 years. This map shows estimated needs over the 20 years period from 2022 to 2042 for each county in North Carolina. Surveys showed that 36 counties have estimated capital needs of $1 to $20 million, 24 counties with $20 to $40 million, 19 counties with $40 to $60 million, 8 counties with $60 to $80 million, 5 counties with $80 to $100 million, and 8 counties with $100 to $300 million. Johnston County is the one with the highest needs of $290 million, followed by Wake County with $190 million. And the North Carolina's total estimated needs reported in 2022 survey is $4.2 billion. This poster I presented in 2023 National On-Site Wastewater Mega Conference. And just wanted to share that decentralized wastewater treatment systems can provide underserved and economically challenged communities with viable, more economical, or cost-effective options for wastewater collection, treatment, and disposal. Such systems may be a solution for those who are unable to afford expansion of the sewer line, connection cost, and associated usage fees in the area with no centralized wastewater treatment facilities. Decentralized wastewater treatment system provide our citizens with a controlled, safe, environmentally friendly alternative that aid in the overall protection of public health. On-site wastewater treatment systems database update is another project ongoing in our branch. This chart shows distribution of on-site system in 17 watersheds of North Carolina, and this information is based upon 1990 census. The last three bars represents overall wastewater treatment infrastructure in North Carolina. What we see here is 50% of housing units have access to public sewers, 48% uses septic systems, and 2% relies on other systems such as privies, outhouse, and straight pipe directly discharging to streams or ditches. When we look at the watershed scale, septic system uses the range from 39% to 82%. In 12 of the 17 river basins in North Carolina, more than 50% of the population uses septic systems. So by looking at the percentage of on-site system users, nutrient loading from on-site system to water bodies can be substantial and significant. And also, let's not forget this information is based on census 1990. 2000, 2010, and 2020 census did not include wastewater treatment information in their survey. So we are in the process of updating on-site system information using available information such as monthly activities report submitted by counties. This map shows the average number of septic systems installed in all 100 North Carolina counties for the period of 2010 to 2020. The number of new systems installed ranges from 7 systems per year to 787 systems per year. And little over 50% of the counties have 51 to 200 systems installed per year. What we see in this map is the average number of malfunctioning septic systems repaired in all 100 counties of North Carolina. The counties with lighter color have lower number of repairs, and the counties with darker color have higher number of repair systems. So the 65 counties have less than 50 systems repaired per year, and whereas the one county has 431 system repaired per year. Estimated number of on-site systems through 2020 are presented in this map. Total number of systems were estimated using census data and monthly activities report submitted by counties. What we see here is 40 counties have less than 15,000 systems, 35 counties have 15,000 to 30,000 systems. 16 counties have more than 30,000 and less than 45,000 systems. 8 counties have more than 45 and less than 55,000 systems. And 1 county has 74,420 systems. And all these numbers are estimated numbers. Serving the underserved, addressing PFAS and other contaminants in septic systems and private wells. This is another ongoing project in our branch. This project was supported by EPA's multipurpose grant program for the state and the tribes. EPA encourages grantee to consider using funds to address PFAS, and advancing in environmental justice and tackling climate change are also some of the important priorities of the grantor. If communities served by municipal water and sewer are struggling to deal with PFAS contamination, then the communities served by individual wastewater and water system face even tougher struggle, as these infrastructures are not federally regulated. So the overarching goal of this study was to gain a better understanding of the presence and concentration of traditional and emerging contaminants in on-site system and private drinking water wells in some economically distressed communities of eastern North Carolina. There are over 4 million occupied homes in North Carolina, and approximately 50% use on-site wastewater treatment system to collect, treat, and disperse their wastewater. And approximately 25% of the population use private wells as a source of their drinking water. The percentage of private wastewater and private water users in North Carolina is nearly double compared to the national level. Septic system and drinking water wells are utilized in all 100 counties of North Carolina, and the number of users per county varies, ranging from 14% to 92% of county's population for septic systems and 4% to 86% for well water users. PFAS refers to a group of man-made chemicals. They are widely used in commercial and consumer products such as food packaging, water and stain repellent fabrics, non-stick products, and firefighting foams. They are also commonly used in industrial processes and manufacturing. Because of their widespread use, these compounds are present in household and industrial waste, air emissions, and wastewater discharges. Regardless of how they enter the environment, the chemical structure of PFAS prevents them from breaking down easily, which is why they are known as forever chemicals. They will continue to cycle through our environment indefinitely unless they are intercepted and removed through the treatment process. And North Carolina is the third highest state for the PFAS exposure. A variety of PFAS have been detected in North Carolina's drinking water source, groundwater, surface water, soil, air, and aquatic life. EPA detected PFAS in the drinking water of 20 public water systems across 11 counties in North Carolina. And NCDEQ has been working with public water systems to prepare for the proposed regulations and assess PFAS level in drinking water system across the state. And DEQ is also utilizing federal funding under the bipartisan infrastructure law to help address PFAS contamination. And even with 50% of population being on septic and 25% using private drinking water wells, there is no federal or state funding assistance for PFAS testing or for private water and wastewater systems. Bladen, Cumberland, and Robson counties were selected for these studies. These counties were selected because of the predominance of low-income communities using on-site wastewater treatment systems and private drinking water wells. Area median income of these counties is much lower than state's median income. Uh, the state median income is $60,516 per year. Also, one quarter of the person in the Bladen and Robson counties are in poverty. Let's take a look at the location of these counties. All three counties borders each other, and Bladen County is the location of Chemours manufacturing plants, which is formerly called DuPont. Chemours is a manufacturer of chemicals and in the past it has produced PFOA, PFAS, and currently produces Genex. 18 housing units in low-income community within the 25 miles of Chemours plants were selected for these studies. These housing units are served by both private water and wastewater treatment system. And this is the Chemours industrial plants, and five study sites were located. These five study sites were located upstreams, and 13 study sites are located uh, and the 13 study sites are located on the downstream of Cape Fear River from Chemours industrial plants. This industrial plants has been identified as the source of an PFAS. In 2017, the North Carolina Department of Health and Human Services was notified that Genex was found in drinking water source from the lower Cape Fear River. Subsequent studies found Genex and other emerging PFAS in the rivers as well as in private drinking water wells, rainwater, and the other bodies of the water near the facilities. The possible effect of PFAS are impacting neighboring counties such as Cumberland, Robson, Bladen that have communities within the 25 miles of the facility. Distribution of water and wastewater infrastructure in the study communities are presented here in this table. Percentage of population using septic and private wells are much higher in Bladen and Robson County compared to the state's percentage of private water and wastewater users. Let's take a look at how septic systems are doing in these three counties. 10 years average number of operation permit issued for new system installation and repair of malfunctioning systems are about 55% and 45% respectively. What that means is higher percentage of septic systems are failing in these counties. And we knew that septic systems require routine operation and maintenance to help them keep it functioning properly. And if a homeowners can barely put food on the table or pay for necessary medicines, it comes as no surprise they cannot pay to have a septic system or private well issue addressed. And and the community's drinking water quality and wastewater disposal should not be influenced by the community's wealth and or the racial demographics. Safe drinking water and safe disposal of wastewater are basic human rights. East Carolina University was contracted for study site selection, water and wastewater sample collection, and sample analysis. Water and wastewater samples were collected from all 18 study sites, transported to the lab, and analyzed following EPA-approved quality assurance project plan. Wastewater samples were collected from the outlet portion of the septic tank. Each tank was pumped out after sample was collected. Water samples were collected from the spigots. Prior to collecting samples, water were allowed to run for a few minutes, and then a sample was collected by placing open bottle underneath the spigot. Parameters such as pH, oxidation reduction potential, temperature, and specific conductance of water and wastewater were measured in the field. Separate bottles were filled for a nutrient, bacteria, and synthetic chemical analysis at each sampling locations. Synthetic chemicals analyzed were PFOA, PFOS, and Genex. The bottle filled with the samples were placed in ice-filled cooler for the transport to lab at the East Carolina University for sample analysis. Samples were processed within the holding time. Water and wastewater samples were analyzed for nutrient, bacteria, and synthetic chemicals at different laboratories of East Carolina University. All samples were analyzed for total dissolved nitrogen, total suspended solid, nitrate, total gelal nitrogen, dissolved organic carbon, and chloride. All water and wastewater samples were analyzed to identify presence and concentration of synthetic compounds. PFAS compounds analyzed for this study were PFOA, PFOS, and GenX. These analyses were conducted in the chemistry department lab at ECU. Samples for E. coli and total coliform were analyzed in the Environmental Health Laboratory at ECU. Table shows concentration of nitrate nitrogen and ammonium nitrogen in private wells and septic system effluent. None of the sample collected from the private drinking water well exceeded the maximum contamination level of 10 mg per liter. The concentration of nitrate in the water supply wells ranged from less than 0.0 mg per liter at several sites to 3.2 mg per liter at one site. Wastewater sample from septic tanks at the sites had less than 0.4 mg per liter nitrate. And this was expected because of the reducing condition in the septic tanks, which favors ammonia nitrogen form of nitrogen rather than nitrate. Ammonium concentration in wastewater ranged from 28 mg per liter at sites 4 to 166 mg per liter at site 15. All well water sample had ammonium concentration below 1 mg per liter except for the site 15. Substantially lower concentration of ammonia in drinking water wells indicates that wastewater discharge to the subsurface from the septic system was not influencing the drinking water well with regards to nitrogen. Concentration of PFOA, PFOS, and GenX in drinking water wells are presented in this table. Let's take a look at the concentration of PFOA in drinking water wells. Concentration of PFOA ranges from below detection level to 72.4 parts per trillion. PFOA in 7 sites were below detection level and 11 of the 18 wells had detectable level of PFOA. Furthermore, at each of those 11 sites, the concentrations of PFOA were above the EPA's health advisory level of 0.004 parts per trillion. Let's take a look at the PFOS concentration in private drinking water wells. There were 7 sites that had detectable level of PFOS. At all 7 sites, PFOS concentration exceeded the EPA's health advisory level of 0.02 parts per trillion. And concentration of GenX were detected in 7 of the 18 private drinking water wells. At 4 of those sites, the GenX concentration exceeded the EPA's health advisory level of 10 parts per trillion. What we see in this slide is private drinking water wells used in this study are ranked from 1 to 18 based on health advisory level. Water in the well ranked with 1 has a high negative human health outcomes, whereas the well ranked with 18 poses less risk. With regards to the potential of negative human health outcomes, 11 of 18 sites exhibited some risks due to exceeding the health advisory level for PFOA, PFOS, and GenX. The site with highest potential for negative outcomes were well 17, 15, 9, and 8. 9 and 18. All these wells are within the Bladen County, downstream from the Chemours plant. 3 of the 4 sites in Cumberland County and upstream from the Chemours were ranked between 12 and 14, and thus, the water poses less risk there. This may be related to influence of the wastewater discharge from the plants and its effect on downstream communities, but more investigation would be required for the confirmation. Concentration of PFOA, PFOS, and GenX in water and wastewater samples are presented here in this table. PFOA was detected in the wastewater at 16 sites. At sites 3, 9, 10, 13, 15, and 17, concentration of PFOA were greater in the private wells relative to wastewater. So it is likely that water supply is the source of PFOA for those homes. Detectable concentration of PFOS was found in all wastewater samples excluding Site 1. Except in the Site 18, PFOS was found in higher concentration in wastewater than the water supply wells. So it is likely that the main source of PFOS may be from origins other than the water supply, but more research is suggested for the further exploration. Wastewater at all 18 sites had detectable concentrations of GenX, and the GenX concentration in wastewater ranged from 0.2 to 221 parts per trillion. At Site 5, 6, and 10, private drinking water wells had higher concentration of GenX than the wastewater. So the contaminated groundwater may have been the main source of GenX detected in the wastewater. For the sites with a higher concentration of PFAS, the wastewater than in the private drinking water wells, the main source of PFAS was from origins other than uh, sources such as in summary, 61% of drinking water wells sample contain PFOA that exceeded the health advisory label of 0.004 parts per trillion. 39% of drinking water wells sample contain PFOS that exceeded health advisory label of 0.02 parts per trillion. 23% of the drinking water well sample contain GenX that exceeded health advisory label of 10 parts per trillion. None of the well water sample tested positive for E. coli. One of the 18 sites was positive for total coliform. Nitrate concentration in the water supplies wells were all below 10 milligram per liter. Private wells and septic systems are critical to development and growth in North Carolina, providing rural areas with drinking water and wastewater disposal. These systems are an effective, critical, and permanent component of our water and wastewater infrastructure. Based on lab analysis results, the main threat to human health in this region with regards to contamination of private wells was with the synthetic chemicals PFOS, PFOA, and GenX. It is important that private drinking water wells in this region are routinely monitored for these chemicals and filtration systems or alternative source of water be provided where needed to protect public health. There are no federal or state programs providing funding for PFAS testing in private wells. Also, only a handful of funding programs are currently available to assist homeowners in repairing or replacing malfunctioning septic systems. So, both state and local officials must contend with how to safeguard public health and protect the environment without burdening underprivileged, underserved residents with the substantial cost for maintaining integrity of their water and wastewater infrastructures. Flyers, brochures, and faxes are remarkably effective ways of getting messages out to the public, especially in the rural communities. Public education is critical in promoting proper system use and management for the prevention of non-point source pollution from on-site wastewater systems. These are lists of the faxes and door hangers we have developed. These educational materials were designed and published to assist homeowners and others utilizing septic systems. If you are interested in using any of these documents, please let me know and I will manage to send them to you free of cost. These documents can also be downloaded online as well, and a web address is presented here. Understanding and protecting your septic system. This brochure has information about how does septic system work, signs of possible septic system failure, and what should and should not be doing with your septic system. What to do with your septic system in flooding conditions. This brochure provides information on handling septic system before, during, and after flooding. This brochure is available in the form of door hanger as well. If you have any questions, I can be reached at 919-707-5063, or you can email me at susma.pradhan@dhhs.nc.gov. Thank you.